Hi students, good morning everybody. This is Hari Prasanna. In number 3, we are going to start unit 3, which is the applications of congruence. First we see the topics in this unit. First one, divisibility tests. Second, the perpetual calendar. The third one is round robin tournaments. Fourth one is computer file storage and hashing functions. And the fifth one is Wilson's theorem and Fermat's little theorem. Next, pseudo primes, Euler's theorem, Euler's pi function, and the ninth one is the sum and number of divisors. And the last topic of this unit is perfect numbers and Mersenne primes. Okay. Now, first we see the divisibility tests or tests of divisibility. First we see the theorems. We use the congruent. Already we have learned the congruence in second unit. What is the use of it? We can use the congruence to test whether a given integer is divisible by another integer. A number inko number to divisible avutunda leda check cheyadani kuda we use the congruence. These tests may be based on the decimal notational system or binary notational system. I think all of you know decimal notation system. See here, suppose n is equal to 326. It means 326. 300. See here, 326. I think all of you know how to read it. 326. 6 is in last digit. From right, it is last digit. Okay, from right, it is last digit. See here, 6. We read it as 26. 20 means 2 into 10. Next, 326 antunamante 3 into 100, which means 3 into 10 square, 100 means plus 2 into 10. చూడండమ్మా 3 into 100, 300 కావాలంటే కానీ దాన్ని 10 స్క్వేర్గా రాస్తున్నాం, ప్లస్ 20 చదువుతున్నాం. సో 2 into 10 plus 6. It can be written as 326. 3 into 10 square plus 2 into 10 plus 6. This means 10 power 1. It is constant. That's why every number in decimal system can be written as like this. You assume the last one is A0. 6 is A0. Its previous number 2 into 10 means A into 10. This is A0 plus back side. You come to left side. Start with right side. Assume this is A0. 6 is A0 plus come to left side. Then the next one is A1 into 10. Assume A1 is 2. A1 into 10 power 1. Next come to left. Then the next one is A2 into 10 square. Assume A2 is 3. Okay, like that. So suppose this is 3-digit number. So you get up to 10 square. Suppose it is m digit number ankondi, you get up to m minus 1 digits. So every number in decimal system can be written in the form of n is equal to am 10 power m plus am minus 1 10 power m minus 1 plus a1 10 power 1 plus a0. I think all of you understand it. Now you observe once again this one, you can easily understand. Now I am writing a integer n in the decimal system can be written like this. It is a positive integer, n be a positive integer. You assume n is 326, which is positive integer, can be written in the decimal system like this, no doubt, where am is not equal to 0. That means here a1 is not equal to 0, right? 0 less than or equal to ai less than 10, 0 less than or equal to I less than m minus 1. This is the given number. Then The statement is 2 divides n if and only if 2 divides a naught. Second one, if 3 divides n if and only if 3 divides summation of ai, small a ma, put small a like this. Next one, 4 divides n if and only if 4 divides a naught plus 2a1. Fourth one, 5 digits n implies if and only if 5 divides a naught. Fifth one, a divides n if and only if 9 divides sigma ai. It means the complete number, n means complete number. First you understand the first question. 2 divides n means complete given number. 2 divides n if and only if 2 divides last digit. 2 కానీ లాస్ట్ డిజిట్ని డివైడ్ చేస్తుంటే then 2 divides complete number. I think all of you know it. In lower classes you have already known it. Next, 3 divides sigma ai. Sigma ai means you observe here, sigma ai means am plus am minus 1 and so on plus ai. This sum is divisible by 3, then n is divisible by 3. I think all of you know it. You see here, what is the number, what are the coefficients? Am, a minus 1, what are the coefficients? 3 plus 2 plus 6. In the middle, 10 plus 6, 5 plus 6, 11. It is, the sum is not divisible by 3, so the total number n is not divisible by 3. మీకు తెలుసు. అలాగే if the last digit a naught is divisible by 2, then n is divisible by 2. First statement. Is it right? Yes. Here the last digit 6. This is a naught. Here a naught divisible by 2. That's why the total number or complete number given integer divisible by n. మీకు తెలిసిందే, ఇలా స్టేట్మెంట్గా చెప్తున్నారు అంతే. ఇది మనం ప్రూవ్ చేయాలన్నమాట. 2 divides a naught, last digit. A naught is last digit. If 2 divides last digit a naught, then 2 divides total number n, if and only if, two sides. Similarly, if 3 divides n, if and only if 3 divides sum of ai's. Ai's means digits. 4 divides an, 4 divides a naught plus 2a1. A naught means last integer plus 2 into a1. 5 divides n, if and only if 5 divides last digit. If this is 9, correct it ma, correct it, not a, this is 9. 9 divides n, then 9 divides sigma ai, like 3. 3 ke alago 9 kuda same. Okay, and the last one, 11 divides n, if and only if 11 divides sigma minus 1 whole power ai. That means plus ai minus 1 plus ai minus 2. That's it. Alternate. Okay ma, I think all of you know in lower classes these are all, but here we are showing the symbolic form. Okay, you see here we have 10 congruents. Here it is congruents, 10 congruents, 0 mod 2 and mod 5. Mod 5 means 0 mod 5. Once we put a number before modulus, then for the in the same line for the next modulo also with this same value. So it means 10 congruents, there is another line here, 10 congruents 0 mod 2 and 10 congruents 0 mod 5. You observe 10 congruents 0 mod 5 means 5 divides 10 minus 0. What is 10 minus 0? 0. So 5 divides 10. Is it right? Yes. Similarly, 10 congruents 0 mod 2 means 2 divides 10 minus 0. And 2 divides 10. Right. Next, 10 congruent 1 mod 3. What is it means? 10 congruent 1 mod 3. 3 divides 10 minus 1. 9. 3 divides 9. Next, 10 congruents 1 mod 9. 1 mod 9 means 9 divides 10 minus 1. Here also 1. Chapanga indaka. Read it. 10 congruents 1 mod 9 means 9 divides 10 minus 1. Ante 9. 9 divides 9. No doubt. 10 congruence 2 mod 4 means 4 divides 10 minus 2. You write separately. Each line you write separately with 10 congruence. Now what is this? 10 congruence minus 1 mod 11 means 11 divides 10 minus of minus 1 means 11. 11 divides 11. Okay, ma? You change into the 10 base 10 numbers. We take the base 10 numbers. So write like this, each and every one with the congruence 10. Now n can be written as a naught mod 2 and this here a naught is there, a naught mod 5. Then n is equal to sigma ai mod 3 and mod 9. Sigma ai mod 3 and for the second one also sigma ai mod 9 here. And n equal to 2an plus a naught mod m. And for n is equal to sigma minus 1 whole power I ai mod 11. This gives that the required result. Each line, observe each line and write these equations. Write these equations. So from this here you change it is 9. From this theorem we observe which number means n, which number is divisible by 2, which type of number, and that means what is the rule or remembering point here 2 divides n. This gives that, this gives that 2 divides n. How can we say the number is divided by 2? How can we say the number is divided by 3? Without dividing that number completely, just we observe these points and easily we can tell the given number is divisible by 2 or 3 or 4 or 5 or 9 or 11. What about the remaining numbers? There are some remaining. 6. I think all of you know how to tell a number is divisible by 6. If the number is divisible by both 2 and 3, that means both these conditions are satisfied. Then we say the number is divisible by 6. Other numbers are there, prime numbers, 7, 13, like that. Okay. See here. Divisibility by 7 or 13. Divisibility by 7 or 13. Okay, ma. You see here. Let a number an is equal to ak minus 1, ak minus 2, a1, a0 is divisible by 7 or 13 if, it means if and only if 3 digits a2, a1, a0 minus a5, a4, a3 plus a8, a7, a6 is divisible by 7 or 13. You assume by 7. R13 kuda ide property by 7 anukunna. Divisibility by 7. Suppose you write a number like this. So let n is equal to like this. There is 1 is also fourth digit ga left side 1 kuda undanukondi. The first digit is a0, second digit is a1, third digit is a2. First you see here, if and only if this one. What is the given number? This is the given number. This is the given number. First let n is equal to this one. It can be written as, first you write these 3 digits. దీనిలో నేను 3నే పెట్టానమ్మా, ఫోర్త్ వన్ కూడా ఉందనుకోండి, సపోజ్ 1 ఎంత ఉందనుకోండి. ఫస్ట్ యూ లెట్ ద 3 లాస్ట్ 3 digits మీన్స్ a2, a1, a0. రైట్ దిస్. దీనిలో నుంచి ఇట్లా వరుసగా ఉంటాయి కదా, ఏమో 9 digits ఉన్నాయనుకోండి. దీంట్లో లాస్ట్ రైట్ సైడ్ నుంచి ఫస్ట్ 3 digits యాజ్ ఇట్ ఈస్గా రాయండి. a2, a1, a0 ప్లస్ a2 వరకు అయిపోతే తర్వాత ఏముంటాయి చెప్పండి? a2 వరకు అయిపోయినాయి. నెక్స్ట్ వాట్ ఆర్ ద ప్రీవియస్? నెక్స్ట్ వచ్చేసి a2, a0, a1, a2, ఓకే, a3, a4, a5. సో యూ లెట్ దట్ 3 యాజ్ ఎ బంచ్, a5, a4, a3. 3 digits are there. Already we have seen in the first theorem in decimal system, you know here 3 సింగిల్ డిజిట్ ఒక్కొక్కటి తీసుకుంటే ఇంటూ 10 పెడతాం. అదే రెండు తీసుకుంటే ఇంటూ 100 చేస్తామమ్మా. 3 బంచ్ తీసుకుంటే ఇంటూ 1000 పెడతాం. ఓకే, రైట్ దిస్ n, this is n as, let the first 3 as a bunch and write it, plus the previous bunch with 3 digits A5, A4, A3 into 1000 plus then previous 3 A6, A7, 8 into 1000 square and so on. Now 1000 can be written as, in congruence language, 1000 is same as 1000 congruent minus 1 mod 7. You observe first 7 ma. 13 kuda same process. You assume first 7 it is. 1000 congruence minus 1 mod 7. You observe what is the definition of congruence? A congruent B mod M, which means M divides A minus B. M divides A minus B. Okay? M divides A minus B. Here in place of M, we have 7. M is 7. Now you compare with the given definition. Here M divides 1000 minus of minus 1 means 1000 plus 1, 1001. You observe 7 divides 1001. Is it right or wrong? Check it. Yes, 7 divides 1001. So we can write it as 1000 congruence minus 1 mod 7. Minus 1 mod 7. Now n is equal to A2, A1, A0 plus, for this second bunch, A5, A4, A3, 1000 can be written as minus 1 mod 7. Minus 1 mod 7. Next, for the next one, this bunch into minus 1 whole square mod 7. For each and every one mod 7 is there. So there is no necessary to write mod 7 at each term. So you write that mod 7 last of the equation, end of the equation. Okay, now n is equal to this term plus this bunch into minus 1 plus this bunch into minus 1 square mod 7 is end of the equation. Now this one minus of this bunch, minus 1 whole square means plus 1 of this bunch and so on, last term mod 7. Mod 7. If here observe that the RHS is mod 7 means this is divisible by, here n is divisible by 7 if right hand side of above congruence is divisible by 7 or 13. Chudandama, what is it means? This number, a total number, n congruence, total number mod 7 annaru anukondi. So n minus this number divisible by 7 అని అర్థం. If this bunch is divisible by 7, this is also divisible by 7, then only we have n minus this one divisible by 7. That's why if the terms in RHS divisible by 7, then n divisible by 7. For 13 also same procedure. Suppose divisible by 13, we let a number, this one, then n is equal to this one. Now this one mod 13, 1000 plus 1 divisible by 13 also. Now n can be written as this, right here mod 13, for last step mod 13 here. Now same కాబట్టి రెండిటికి 7 or 13 ఏదైనా ఇదే ప్రొసీజర్. సో యూ నోట్ ఇట్ యాజ్ ఫార్ములా. నోట్ ఇట్ యాజ్ ఫార్ములా. ఏ నెంబర్ ఈజ్ డివిజబుల్ బై 7. ఏ నెంబర్ నేను చెప్తాను రాయండి. ఏ నెంబర్ n ఈజ్ డివిజబుల్ బై 7 or 13 ఇఫ్ దిస్ బంచ్ అమ్మ A2, A1, A0 minus A5, A4, A3 plus A8, A7, A6 is divisible by 7 or 13. 7 or 13. This is theorem number 2. Next see this one, divisible by 37. A number n as it is, ప్రతి దాంట్లో ఇదే, is divisible by 37 if bunch of 3, first 3, same as the previous theorem, a0, a1, a2 minus next left side 3 bunch plus again left side 3 bunch is divisible by 37. Same as the previous one. Same as the previous one. Here by mistake minus padindamma, idi plus. It is plus, correct it. Okay, let n is equal to this. It can be written as same in the theorem 2. As in the theorem 2. Same proof. This one. First 3 bunch plus the left side next 3 bunch into 1000 plus again 3 bunch to left into 1000 square and so on. Here 1000 congruence 1 mod 37. In previous one, here it is minus 1 mod. But here 1000 congruence 1 mod 37. You observe it. Which means 37 divides 1000 minus 1. And 999. See here. 37 divides 999. You observe it. So in previous one we have 1000 congruence minus 1. But here 1000 congruence 1 mod 37. We have, very sorry ma, we have 1000 congruence 1 mod 37. Okay, now n is equal to a2 a1 a0 plus a5 a4 a3 into 1 plus this one. Congruence is 1 mod 1000 is 1 mod 37. In place of 1000 we write 1 mod 37. Next this bunch into 1000 square means 1 square mod 37 like this. Now this n is divisible by 37. If this sum is divisible by 37, if this sum is divisible by 37, then if n is also divisible by 37, then n minus this one must be divisible by 37. So our conclusion is n is divisible by 37 if this bunch is, that means RHS is divisible by 37. This is divisible by 37. Similarly, see the next one, divisible by 101. Like that, like the previous theorems, same number n is a minus a k minus 1, a k minus 2, a1 a0. This is the given number. We are going to show that this is divisible by 101 if there is some, మనం అదేంటో కనుక్కున్నామమ్మా. n is written as 2 bunches. 2 bunches. In previous theorem 2, theorem 3, we take the 3 bunch, 3 as bunch. But here we take 2 as bunch. Right, first 2, a1, a0. What are the previous 2 bunch? a3, a2, like this. So we have 2 numbers plus left 2 numbers bunch into 100 plus 2 numbers kabatti into ఇది 2 1 తర్వాత 2 zeros ma, a5 a0 a4 into 100 square and so on. But we observe 100 congruence minus 1 mod 101. What is it means? A congruence b mod m means m divides a minus b. That means here 101 divides 100 minus of minus 1 means 101. 101 divides 101. No doubt it is. Now, therefore, n is equal to this one mod 101. Now, if this one is divisible by 101, n also divisible by 101, then n minus this number totally divisible by 101. So, what is conclusion? What is conclusion? If this number is divisible by 101, then n is also divisible by 101. N is also divisible by 101. Okay ma? Next theorem, divisible by 2 power h. Same number is divisible by 2 power h if and only if the number represented by the last h digit is divisible by 2 power h. What is it means? n అనేది ఇలా ఉంటే నంబరు ఇది 2 power h తో divisible అవ్వాలంటే, divisible అవుతుందంటే ఎప్పుడంటే the number represented by last h digit is divisible by 2 power h. ఇందులో అంతా divisible అవ్వలేదంటమ్మా. లాస్ట్ h డిజిట్స్ సపోజ్ 2 పవర్ 4 అనుకోండి. 2 పవర్ 4తో ఇది డివైడ్ కావాలి అంటే దీనిలో లాస్ట్ 4 డిజిట్స్ వచ్చేసి డివిజిబుల్ అయితే చాలన్నమాట. అది సపోజ్ 2 పవర్ 5తో డివిజిబుల్ అవ్వాలంటే ఇది రైట్ సైడ్ నుంచి లాస్ట్ 5 డిజిట్స్ 2 పవర్ 5తో డివిజిబుల్ అయితే చాలు. అది వాళ్ళు చెప్పండి. సో హియర్ n can be written as in decimal fractions like this. I think all of you know it. First theorem I explained it. Now 2 power h divides 10 power h and higher powers of 10. It means 2 power h divides 10 power h. Suppose h is 4 అనుకోండి. 2 power 4 divides 10 power 4, 10 power 5, 10 power 6 and so on. అంటే ఇంకా 10 పవర్ 4 అంతకంటే ఎక్కువ పవర్స్ని 2 పవర్ 4 డివైడ్ చేస్తుంది అంటే దానికంటే తక్కువ పవర్స్ ఏముంటాయి? 2 క్యూబ్ అంతేనా? హెచ్ 4 అనుకుంటే ఈ 2 పవర్ 4 కంటే తక్కువ పవర్ ఉన్నాయి అంటే 2 క్యూబ్, 2 స్క్వేర్, అవి డివిజిబుల్ అయితే చాలు దాంతో. నౌ యూ సీమా, నౌ 2 పవర్ హెచ్ డివైడ్స్ 10 పవర్ హెచ్ అండ్ హయ్యర్ పవర్స్ ఆఫ్ 10. ఇట్ ఫాలోస్ దట్ 10 పవర్ 4 అంతకంటే ఎక్కువ ఉన్న వాటన్నిటిని అంటే ఇక్కడ ఇలా రాసుకుంటే సపోజ్ హెచ్ ఇస్ ఈక్వల్ టు నేను 4 అనుకుంటున్నాను. A0 నుంచి ఇక్కడ ఏ పవర్ 4 10 పవర్ 4 వరకు, ఏ పవర్ 4 10 పవర్ 4 వరకు ఉన్నవన్నీ కూడా మనకి డివిజిబుల్ అయిపోతాయట. అంటే వాటి ప్రీవియస్ ఉన్నవి డివిజిబుల్ అయితే చాలు. దట్ మీన్స్ ఇట్ ఫాలోస్ దట్ 2 పవర్ హెచ్ డివైడ్స్ n ఇఫ్ 2 పవర్ హెచ్ డివైడ్స్ AH minus 1 10 పవర్ హెచ్ మైనస్ 1 అండ్ సో ఆన్ A0. ఇక్కడ అర్థమైపోయింది. 2 పవర్ హెచ్ డివైడ్స్ 10 పవర్ హెచ్ అండ్ హైయర్ పవర్స్ ఆఫ్ 10. That means 2 power h divides lower powers of less than h. That means if 2 power h divides n, if 2 power h divides AH minus 1, 10 power h minus 1 and so on up to last term. Okay, ma?